Hello, this is Pablo Garcia. I live in Stockholm and I am a test and quality specialist. I started for Ericsson in 1996 and has since then talked in many conferences, given many courses, and first of all ran many tests and um, tried to help both projects and organizations to make good software. And today I'm going to talk about something that's really close to my heart and my soul, which is doing things right the first time. Well, as I said, I started in 1996 for Ericsson, and I worked in many places. I worked as a test manager, as a project manager, total project manager, and for 1 year I was responsible for Ericsson in India. After that, when I came back in the year 2000, I've been running or worked at least 40 to 45 assignments. And one of the things I really like is that I've been teaching lots of midwives and nurses and doctors in user acceptance testing in many hospitals actually here in Sweden. So I'm based in Stockholm and I live in Sweden. One thing that happened to me in Ericsson is that I was a project manager, and when the program manager position was free, I sent in my CV for it, and just the next day I got denied and said thank you, but no thank you. So I went to the manager and asked why didn't you choose me? And this is exactly what the manager said: we need strong and active project managers running the program management. And I said, why do you do that? The ones that can fix the problems that arise, you know. And I said, but hey, I've been working here for many years, and you look at my projects, they never run into trouble because I make sure that they don't. We do things right the first time. And he didn't understand it. He said, hey, no, but we really need strong and active project managers for the program manager role. So he didn't really understand what I meant. And that was actually the first step of me leaving Ericsson and searching for other places where it was actually accepted to do things right the first time. This is what we're going to talk about. We're going to talk about waste first, and we all know that waste is just waste. You throw away time and resources in nothing, actually. Nothing gets back. Technical debt, we're going to talk about also. The cost of bad quality, how much is that? What is the real problem? Because it's not just we don't have enough developers, or we don't have enough teams, or we don't have enough testers. That's not the real problem. There's a major problem that arises from amongst other that. What can we do about it? Also, a solution that I have seen worked very well. And also, if there's any questions, I can take them too. So we're going to go straight into it. So waste. What is waste? So a common procedure of running IT projects is that we write requirements, high-level requirements or low-level requirements. Anyway, we define what's going to be done, and we order it. It could be within your own IT organization, or it can be an external provider of software, an external provider of software. That can do it, but you still order it. You send the requirement, say this is what we want to be done. If it's agile, it's the sprint planning meeting. This is what I want to be done. Then the things are developed and tested, and then they're delivered after that. After that, it's run to acceptance test. So if that would be the end of the story of that code, where it goes from an idea until the customer is happy, then we're there. We're doing things right the first time. But the problem is that many times, or actually most of the times, I see products getting into production, they have many bugs. They have many times serious bugs, but also unserious bugs. That means that we're not done when it's delivered. Many people think, oh, we're delivered, we're done. No, we're not done. It's just actually many times the beginning of the code or of the system or the part of the system. This is what happens. We send out many bugs, so we have to fix them. And when we fix them, we have to re-deliver them again. But then we're done then, aren't we? Aren't we ready then? No. Most of the times it actually goes back out again and they say there's many new bugs that came out in production. So we have to fix those too. And after a while, well, we're done now. I mean, there was just 10 bugs, and we fixed them and we put them in production again. And we're happy. And then the next day, the customer comes back and says, yes, but we still have 4 or 5 new bugs in production. Just goes on and goes on and goes on. Some people call it the cockroach approach. You're hungry in the night, you wake up, you go to the kitchen, you open the kitchen door, you lit up the light, and you see 2 cockroaches on the floor, or 1 cockroach on the floor. You kill it, and you go, yes, I'm done. There's no more cockroaches. Is that what you think? Exactly. That's not what you think. Because next day you're going to go back and there's 3 cockroaches on the floor. I mean, you need a deeper cleansing or a deeper way of doing things to make sure that there are no bugs. And that will always be cheaper, actually. There's always exemptions to every rule, but almost always it is cheaper and faster to do things right the first time. I'm going to talk more about exactly that in a moment. So this is many times what happens. We actually have systems with problems in production over time. I mean, the system might live 5 or 10 years, and we will have it with problems in production. That creates a big problem, especially economic, because we're going to pay for fixing the bugs that never should have been made from the beginning during many years. Very expensive maintenance. Sometimes we have to limit the functionality, because in production there's some functionality we can't use, but we still have to use it, you know. Sometimes also you see that the project is terminated. And now I have turned off my phone. Sorry for that. But it was a good song, wasn't it? Okay. So what's really happening within the teams when this happens with a lot of wasted time and productivity? Let's say that we have a new sprint team that comes up. They're going to work together and they set up the time frame. They're going to work 2 or 3 weeks. I don't know. Doesn't matter. Anyway, let's say 2 weeks, and they start working on the project. They have a sprint planning meeting. And after the sprint planning meeting, everybody feels that they know exactly what to do and how to do it. They start working. And after 2 weeks, well, the last 2 days or 3 days, they do the catch-up days, and they test everything, and they retest it if things are going to have to be finished. And then it goes into production. So after sprint 1, they make release 1.1, the version goes in production, and everybody's happy, aren't we? Of course we're happy, because we have delivered. So that's over, isn't it? Of course, we start sprint 2. But not many days into sprint 2, we get surprised, or we get a surprise. A bug has been found in production, or maybe 2 or 3. And it's actually a bug that comes from the code we wrote in the first sprint. So we fix that fast, you know, and then we deliver version 1.1. It took just a little bit of time from sprint 2, didn't it? Yeah, just a little bit of time. And we did a new release. So that's fine, isn't it? Now we are done, aren't we? Did we kill all the cockroaches in sprint 1? I don't know. We deliver sprint 2, so we get a release. Yeah, there you go. So we get a release called version 2.0. So what happened in sprint 2? Yeah, we were disturbed a little bit from the code that was not finished in sprint 1. But we had to do 2 deliveries into production. So we triplicated that. So it took a little bit of job, didn't it? Let's go to sprint 3. We have the sprint planning meeting. We have everything in place. What happens then? Not soon after, we get surprised from the code that we delivered in sprint 2, the yellow code, and the code we delivered in sprint 1. And that makes us lose time, not just because of the blue code, sprint 1, and the yellow code, sprint 2, the yellow code in sprint 2. No, we have to do deliveries within the sprint because things are in production and had to be changed fast. So we end up losing a lot of time, both because we fix code that should fix bugs that should never have been created. And on top of that, we have to create 3 deliveries into production, which also can cause more problems. And then we have sprint 4, and you see where we're going. In sprint 4, we're actually creating 4 different versions, and we're still not done with the code in sprint 1 that we created in sprint 1. This is what happens. And many organizations, they say that in sprint 5, we're not able to create one single new feature. We're not able to create one single new thing at all and deliver. We just fix bugs. And from my point of view, that should never have been created at all from the beginning. So this is what happens in agile organizations. And when I speak about this, I've been speaking about this internationally around 20 times. And when I say this, I see people in the audience always nodding with their heads. That's exactly how we do it. And it's not fun, because you cannot deliver anything new or very few new things. In the beginning of the sprint, you promise a lot because you think that, we killed all the cockroaches, didn't we? And then suddenly you go into the kitchen and you realize that it's 25 cockroaches this morning, or this night when we lit up the lamp. And it just kills your development, the prosperity of the team, just kills the delivery that goes out. And every new thing you deliver, since you delivered the same way you delivered the previous sprints, the new stuff you're creating is also bad as the things you created from before. I'm putting up a pretty dark picture, but it is actually like that. It is that dark out there normally in almost all the places I see. Why does this happen? Why isn't it like this? Well, it's really deep incompetence. The incompetence of not knowing, not making sure you learned how to do things right in the beginning, and not just know how to do it, also evaluate it. What is really put priority in doing things right the first time. You can say, I don't have time, but you can never say, I don't have time to unit test it or to function test it, or I don't have time to write a user story for it. Definition of what you're going to do. You can never say that. You can say, we weren't able to create all the software or all the functions that we're supposed to do. But the functions you create has to be good code. Otherwise, it's just waste. You created systems and product and code that will create more waste for you in the future. Most of the assignments I go to, and they have this problem. I ask them, so can you please do unit testing or agile testing or sprint testing in the team? Even the testers, not just the developers, the testers in the team too. And they say, we don't have time for it. We don't have time to do it properly. And then when I finally speak with the IT manager or the CEO or managing director or whatever, that forces them to do it and says, you have to do component testing, unit testing, and you have to do proper agile testing. The first things the developers tells me, they come to me the next morning and say, Pablo, how do you do it? It's not that they don't have time for it. It's actually that they don't know how to do it. So that's what incompetence means here. I don't have time to, it's very simple to say, I don't have time to write requirements or write a user story. I don't have time to test. There's so much fun to put it in production. Or we have so much hurry. Or we actually promised, we have the lack of resources, but we promised to deliver. What you do there is that you deliver things that are not finished and that will bite your ass for many sprints to come. There's another thing too, the misconception of agile. People have mainly not read the Agile Manifesto, which is actually the definition of agile. And then they talk about we're working with Scrum, and they haven't looked at the Scrum Alliance definition or the Scrum guide, which just changed a couple of days ago. And it's supposed to change all the time. People have not read it, and they don't even know what it is. The only thing they know is that you shouldn't do it this way. You shouldn't document. You shouldn't test that way. And that is a big problem because it's also incompetence. They don't really know why and to what level should you document or to what level should you test. Roles missing. I'm going to put that up there too. It's really important that everybody is not good at everything. It is impossible for a person in construction to be good at everything. To be good to define how the cement for the foundation of the house is going to be, how to make how to put it in place, the foundation, and also be a specialist in putting up the walls, and be a specialist of putting up the pipes and the roof, and be a specialist of painting the house on the inside. It is impossible for a person to be a software engineer and be really good at everything. It is impossible, let me tell you. So I see many teams that they say, who does the testing? I said, there's many developers, but no one knows how to write user stories properly. They don't know what BDD or TDD is, so the testing is really badly done. And no one knows how to do proper test design, which you have to do in Agile and Sprint testing. So there are roles missing. And they say, yeah, but we'll get better as time comes. Yeah, you will get better as time comes. But it is much faster to learn of other people's mistakes and actually have a person and other, not just the mistakes, other people's winnings also. This is what you need school for, or courses or books, to have a jump up and to know more of how to do things. So you should have an educated tester in every team. And you should have an educated business analyst, or someone that writes down the detailed definition of what's supposed to do in every team. If you don't have that, the definition, the requirements, the user stories will not be properly done. And the testing will not be properly done. Okay? So educated people. And that is one of the problems too, because they don't know how to test, They think they test properly, or they use much time to do testing here, but you can do all the time. You can use up all the time for testing. If you don't know what you're doing the wrong thing anyway. The second to last one is the okay people. You promise without knowing. Can you do this too? Can you do this user story in the sprint also? And somebody goes, okay. And they promise to define it, create it, and test it, and deploy it, without actually thinking it through. How much extra time will that take? This just kills the planning, the time planning within the sprint. It just kills it, okay? So, okay, people, never say, okay. What you say is, thank you. I'm going to take a look at it to see what implication this has to the sprint and to the planning we have. I'll get back to you tomorrow. So that you always have to take, it's called a break or a pause. Always take the pause. Never say okay. Okay? Bad requirements down there. Yes. If you don't have proper requirements, then you don't really know what to do. Shouldn't you ask and say, hey, these requirements are not finished. They're not complete. They're not well defined. They're not unambiguous, Can you please define them for us, or else we will do the wrong thing? And I really like the developers that come up, and testers that come up to the product owner and says, hey, our job is to do everything you want. Everything you want. But if you don't tell us what you really want, we're going to do the wrong thing. And that doesn't mean that we don't have any problem to do that, because we'll be able to do stuff anyway. But you will have a problem. You will not get what you need. If you use that those sentences in that way of discussing with the product owner, then you will get a much bigger positive loop for that. But this is many of the reasons why it happens. There's actually one, and in my point of view, the major one. Nobody asked for better quality. We lack quality requirements in our industry. There are some standards very poorly written and very unread. People don't read them. We have them, but it's not just take a requirement and create the code and test it. It's how big should the quality level be in all our products going out there? Is it a bank? Is it healthcare? Can people die with it? Or is it just a paper or an information site for something? We need to know the quality level, and we should have strict rules of how to do things. So this is something that we really miss. Actually, the major reason, I'm going to get back to that in a moment, okay? Which is really important. I'm going to get back to that. It is that important, so I'll get back to it really, okay? First, we're going to take the questions here. So how much waste is okay? How much do we have to waste? Because we people, we do mistakes, don't we? Of course we do. So how much waste is okay? So two deliveries to production or 2 deliveries to test is okay. It is okay to deliver to production. They find the bug and then we deliver again, okay? But the third time you deliver to test or to production is waste. There's no doubt about it. So code that has to be untouched, unchanged, that should, I mean, if you have to change code, of course you have to change it, you know. But if you have to change code, not because you need to change code for user stories, but you change the code because there was bugs in it, you can do it once. And it is okay because nobody's perfect. But if in sprint 3, you have to write and fix bugs for the code you wrote in sprint 1, as a surprise for you, you know, that it was not planned, that is waste. That is not doing things right the first time. And if you do it for the third time, the delivery, you write more time than if you change and redeliver for the third time, I can most surely promise you that you're in the cockroach problem. There are still cockroaches there, unless you do a proper change in how you do things. Emergency correction and service packs, how should you do that? I mean, everybody has emergencies. Everyone has that, okay? So how do you do that? It's very important to do the emergency correction. If you want to make a swim lane in your Kanban board, do it and put the best teams, the best guys to do it and make the change and put it in production, okay? But that change has to be included in the next sprint or in the current sprint to be properly tested all the way. So it's a temporary correction that goes in production. Most of the corrections I see, they make something, they correct something, and it's really important. It goes in production, and the CEO goes up and gives champagne bottles to the developers and testers that fixed it, or the team that fixed it. They saved the company during the weekend. And very fast after that, we find bugs again. So think about it. Every emergency correction is a temporary correction until we properly quality assured it. Okay? That's how it should be done. If you don't do that, you're actually creating more and more waste for yourself. How many test rounds is okay? 2 test rounds. Normally what I do is that I aim for 1 and it becomes 2. It's fine, you know. But the third test round, it is waste. Both internally in the team, but also to the user acceptance testing. The third test round is waste. You haven't done your job properly. How many stops in productions is okay? You know, that's a good question. I can't answer that, you know. It depends on the quality level of your system, but normally it is 0. It is not okay. But still, the people that fix them, they are the heroes, aren't they? So this is what I normally work with. I go to organizations that have major quality problems, and we start measuring the waste. And 80% of the time they work at work, it's doing things that should have been done before. It's fixing bugs, it's doing activities that should never have arisen if they did things properly the first time. So 80% waste, that's a normal figure. Between 75 and 85% of the time is waste when I get out there. So you see it's 15 to 25% productivity. And if you do things properly, it is actually the other way around. 20% waste, it's very hard to get under 20% waste. You can get to 15, but many times it's not worth it to go down to 15. 20% of your time doing waste or actually doing things, because we're not perfect, it is fine. But 80% should be productivity, at least 80%. And if you look at the numbers, the team that works on the upper layer there, 80-20, if you compare it to the other team that works 20-80, they actually produce 4 times as much. They actually 80% of the time is productivity, instead producing new stuff, instead of 20%. It's 4 times productivity with the same amount of people. Isn't that amazing? This is actually what we have to work with, and it is possible to go this. We call it the quality journey from 20% productivity to 80. We measured it, most of the times we measured it properly. 5.2 times increased productivity is the best we've done. It's amazing with the same amount of people. We continue. We're going to talk about technical debt also, because that's what you create. You have code not following the rules. So if you don't have a proper rule set of how the code should look like, design rules, design patterns, then you have code that is poorly written. And if you fix a bug, it doesn't take 3 hours, it takes 3 days. I've been in projects that are like that. Every developer were allowed to write their own dialect on the code, and it was almost impossible for them to fix anything within a day. And there were other projects that had strict ruling of how the code should be written, with flags internally, so you know exactly where you are all the time, and it was very easy for the developers to fix it. If you don't have that, that is technical debt. That will make you slower in your productivity. Component test not implemented. Do you have automated tests? Yes, we do. How much do you test of the system? We don't know. Much, Pablo. Why do you ask? If you don't know how much you test, both in component test and sprint test or function test or system test, then you don't know what you're missing, you know? And Murphy's rule says that the stuff you're not testing, the stuff you're missing to test, that's where the major bugs are. So many times, component test is not implemented. They do have a pipe, they do have test cases, automated test cases, but it's not implemented properly because they don't even know how much they test. They don't even know how much they should test, which is a question also that you have to have. That's a technical debt that follows the product for the rest of its life. Imagine you have proper design, you have proper component testing and proper sprint testing for the system, automated. So you know in your gut feeling that if you do some changes, it doesn't matter. We know that it's going to be good or bad after we test it properly with our properly created test design tests, before it goes to production. So we don't have to redo stuff that way. We can make a small change or a big change for the system. We know the product is good enough. So if you don't implement it, it's not just have it, it's implement it properly. How you do it comes later in this presentation. System test is not automated. You have people clicking around, and it's very, very, very fast. It just gets too much to test manually. Next slide. It's impossible to test everything manual. Continuous integration is not implemented. So many times the bug is found too late for the developer to understand that I did that bug. And there's a really good thing that happens when the feedback loop is very short and the developer checks in the code and automatically finds it says this test case didn't pass. Either it's component test, sprint test, or system test, doesn't matter. Goes back and it goes, oh, okay. That's what the developer says. Oh, okay, now I understand the problem I did. And he will not do the same thing again. It's not just about creating good code and fixing the bugs. It's about learning how to do proper code and not do the same mistakes again and again and again. Missing requirements, missing design documentation, lack of competence creates technical debt. And just look at this picture. You see, the sprint 1, everything has to be tested. Yeah, we do it manually. In sprint 2, the thing we did in sprint 1, that is behind us. So if we didn't do things properly the first time, it will haunt us. It will be like a backpack on our back. We still have no component testing, which means we have no way of doing proper regression testing of the code from sprint 1. We have no automated sprint tests or function test or system test, which does that we don't know. Well, we can try to manually test them this time in sprint 2. But in sprint 3, it's not only that we don't have time to do the test anymore, it's that we don't have time to even do it properly, testing and automating the new stuff we create in sprint 3. So it just goes worse and worse and worse. We have a backpack of technical debt that's going to be so heavy that it's going to throw us backwards when we try to walk. It is that bad. So when you see a team which has a lot of a big system with really poorly written tests, really poorly written requirements, and really poorly written design, I really feel sorry for them. It's just not just fix it, There's a big mountain that you have to pass, but you can make that mountain smaller. You can make that mountain smaller. And I'm going to say it right away. You don't have to write all the users the test automated test case for unit tests for all the code. Just write it for the new and changed code. Same thing for function test and sprint test. You write test cases and automated test cases you need to test for all the new functions. Okay? And then in the sprint, okay? And then the system test the same thing. You start off with what you have, just look forward forget the thing backward. That means after half a year, much of the code will be changed. So you will have proper unit tests for the code. You will have proper sprint test and function test and system test for the functions because they have been touched and changed. So that is just one of the solutions to do it. Just telling you a solution for it, not just how bad it is. But I really like this. Okay, this is a big picture. I think it was on the Ford factory. This comes from. The bitterness of poor quality remains long after the sweetness of low price is forgotten. Just don't forget that. Because the problem is that how much does a bad system really cost? Imagine that you're working for a provider of software and you create poor software and you had to redo it and redo it and redo it and redo it. I mean, you are creating 4, 5, 6 softwares. The cost of that instead of just one. But Pablo, people say, doesn't it cost very much? It costs very much it's an investment. It's an investment to do proper testing, proper unit testing with automation, proper CI/CD pipe, proper sprint test and function test. It's a very high investment. And all the proof I have is that it's not even an investment. Within the same sprint that you start doing things right the first time, it's paid back. It actually goes just a little bit faster. You deliver at least the same as you would otherwise. So it's not tiring, it's not heavy, it will not push you down. It's actually the new code you write in that sprint, you will really know that it's really good very fast in the sprint. So you will be able to do things properly. You understand? I mean, within the sprint, it's payback. And that thing you did there will even pay back more for every sprint in the future. So it's no investment to do things right the first time. It pays back right away. So what is the real problem here? The real problem is not that it costs more, that we need another team. The real problem is that if you don't have a fast-paced, efficient and effective IT organization that creates software, you will not be able to keep up and cope up as a company against your competitors. There is no way that you can have a new idea. You go at a fair or something, you have a new idea, and you have a proof of concept within 1 or 2 months of the new idea of a big system. It's not possible. Most organizations I work for, they have a new idea, and the developer says you will have a proof of concept in 6 months from now, or 4 months from now, or 3 months from now, but it actually takes them 2 years to make a proper system, a proper new release. And it's not possible to think about new ideas if it takes 1 or 2 years to actually get in production. Even if you do agile, it's supposed to go fast. Yes, but you don't really get there anyway. And on the other hand, I've actually seen in long meetings serious problems, actually COVID problems. I can't tell you more detail, but COVID introduced problem for a company, and the team in the meeting, there was over 25 people in the meeting, and you have everybody in the meeting. How are we going to solve this? And the project managers, the product owners, they tell how important this is. And there was a couple of guys in the other end, and in the end of the meeting, after 1.5 hours, they said, "Okay, we have an idea. Do you want us to show you what we've done?" Within 1.5 hours, they have solved this really serious problem for this company. And they showed it, and the week after that, it was in production. It's amazing, isn't it? I've seen that being done. And this system has been used for, the week after it was used for over 10,000 people were using this system. So it is possible to really do things like that. You have an idea. This is how we're going to get number one in our industry, in the business, and to really make money, to really make a difference. And 2 weeks later, you can do it. It is possible. It takes time to get there. It takes 1 to 1.5 to 2 years to 2.5 years to get there, but it is possible to get there. But when you're there, your company will probably be number one. So what can we do about it? Okay, I'll go to the next one. So I told you I'm going to talk about the major problem we have. The absolutely major problem we have is the hero the hero challenge, if you may say. It is very simple to incentivize, give higher salary to people that fix the problem in production during the weekend. They are the heroes, okay? But if you do that, there is no incentive to do proper work from the beginning. One of my places I worked at, there was two developers that fixed a big problem in production during the weekend. On Tuesday, we were all called up for a meeting. We're talking about 250 people in the canteen, and the CEO gave them one bottle of champagne each and said, "Thank you for saving our company." And Sara Nordling, a wonderful test specialist that showed me testing in the 90s, she asked, "Hey, I have a question." And the CEO turned around and she said, "Did you check who made the bugs?" And within 5 seconds, all the champagne delivery for all people were shut down. Everybody knew the developers that fixed the bugs in production were the ones that created the bugs in the first place. And that is how you have to think. Drama-free production. If you really focus on that, everything will be focused on the same thing, doing things right the first time. So take away the heroes and aim for drama-free production development. It's really simple. It's really hard to do that, because if you go in at any company, I go in and say, "Who's the best developer?" And they go, "It's that developer and that developer." "Who's the best team?" "It's that team. We call them the Tiger team. They fix everything." But what you actually do when you do these incentive models is that in the back of their head, you don't give them any reason to do anything right the first time. And we have to get away from that. The incentive model is wrong. The people doing things right the first time are not seen, have the lowest salary, and I've seen that many times. The manager goes to the developer and says, "But on the tester, I don't really know what you do here, so I can't raise your salary. I don't see you anywhere. You're not seen, you know." And that's how it should be. People should not be seen. They will actually deliver stuff properly. So go from hero-driven development to drama-free. This picture is good. I have nothing to say, and I say it regularly. How do you identify these people? It is hard to identify them, but you look at the production, the system that go into production, and you go, "This part is made by this guy. There has been no bugs for the last 5 deliveries." Amazing, isn't it? Even if they work as team and need to have the same responsibility, the agile team, everyone in the team, you should incentivize these guys. They say, "This is really well done, and I've done it," and it really flips around the values in the teams and the company. The core values change, you know. It's not the heroes anymore. It's the guys that really delivers good software. That's a good place to start. So one thing I said was missing is quality requirements. Really missing. So all projects, products, and organizations and suppliers are different. The quality requirements should therefore be unique. So it's very hard for me to tell you exactly how it should be done, okay? How you do it, how to get them in place. You meet the supplier and investigate. I'm taking this from the customer side. You meet the supplier and investigate how they work with quality and testing. And then you create a process together with them, how to do it, and put this process as a requirement from you as a customer of what you want. So you have to tell them how you want, not just what you want, how you want the things done. So this is when you do it from outside. It's very interesting, you know. Okay, so what should be included in it? Test levels should be included. This is just a way, some ideas of it, okay? I'm going to make more detail in a moment. Unit test, function test, system test, acceptance test, user acceptance test, okay? Performance test, usability test. Those have to be defined in the quality requirement and also stated when are they done. Every one of them should have a definition of done, or exit criteria as we used to call them. And an entry criteria, a definition for ready also has to be for every one of these. Test coverage, that's the test coverage is actually fun. And not just how much should be tested, but how deep should things be tested. Look positive and negative testing and um, um, depth in testing. You can look that up, okay? But positive and negative testing. Positive testing is very shallow. Negative testing goes very deep. You should also look at exploratory testing with Michael Bolton and James Bach, their ideas. It's amazing. There's a very good also of talking about test coverage. The error rate. How many errors can be left? And of what type can be accepted? This is really good. When you go from hero mentality to drama-free mentality, you have to start talking in a realistic way about errors. We're not looking for a perfect system without any bugs. We're looking to know how bad or how good the system is and make an informed decision before it goes into production. So we have all these things have to be included in the quality requirements. Often missed stability requirements. Also automated test case, how much of the functionality should be automated. Code quality. Is the code documented? Does the code follow code standards? I have, as a customer, actually written the requirements. You have to follow this code standard. Because I'm buying software, and I really want the software to be cheap, or not cheap, but actually efficient and effective. Both money-wise, but I don't want it to take 3 or 4 sprints to get it changed because there's so many other changes to be done. And we all know that it is like that. So this should actually be from the top in the quality requirements. Error handling for other things. And the last slide I'm going to show is this one. This is just an idea of test levels. You have business requirements in the top. This is just an idea, okay? This is the picture I bring up when I start thinking about it. You have the requirement bugs in the beginning, requirement review. When you start your sprint planning meeting, or when you start the sprint after the sprint planning meeting, do proper reviews of every user story and have the whole team being there, because everybody needs to know these things that come up there. Proper review of all user stories. Start with that, and you will take away a lot of waste and technical debt. Then you develop behind it. Unit test. Unit tests should also always include static analysis. Static analysis, look that up, okay? It's an automated way of finding bugs in the code. Many people say, if you have no test, start with static analysis. It's the most bang for the buck, or bang for the crown, as we say here in Sweden. Automation is crucial. Code coverage, code line coverage, which is the simplest way of measuring how much of the code you test. Code line coverage, how much percent of the code that has been touched during your testing has to be at least 80%. If you have zero from start from zero, but you see really big effects when you pass 50% of code line coverage, because then you get another feeling, the stomach ulcer you've been creating of not knowing how good the things are in production. That the ulcer coefficient is actually going down, because the products will be much more stable, much less bugs in production when you pass 50%. It's really interesting. I speak with many developers about this, and they talk about that. When you pass 50%, there's a major change in the complete system. But you pass 80, and then you can do things actually within 1.5 hours sometimes. Not always. You have to think of maintainability to make sure that it has to be maintainable. The function test, or that we call sprint test nowadays, that's what the tester does within the sprint. They should have, the goal should be of finding bugs, exploratory testing wise. That's a manual part of it, or actually a brainial part of it. But then automate also should be the work of the tester, or with help of a developer. What part of all the testing that they did manually or brainily has to be automated. And it has to be, normally we say it is actually 80 or 100% coverage of the tests. How deep should the test cases be also is very important, I can't go deeper into this, but The shallow testing, 100% shallow testing, but also deeper in the most important parts. But that is something an experienced tester can tell you, which do proper test design. Automation is crucial there too. It's crucial. It's crucial to have automated functions test or sprint test or agile tests. It is crucial. And it's separated from component test or unit test. It is separated test cases. The component test look for codes in the bugs in the code, and the sprint test look for bugs in the functions. Okay, that's why it's code line coverage and requirement coverage. Then we have system test. System test is also very important. And if you do it right, you can have a system test team that creates automated test cases that you can run in the CI/CD pipeline within your sprint. It's amazing, isn't it? You have, when you check in, you do unit tests, function tests, sprint test, and system test at the same time right away. It's amazing. We really find bugs there. It's hard to get there, takes time, but it's always worth it. And the system test is the same thing, 100% requirement coverage. And the system test normally is not aimed to find bugs, as I said about James Buck and Michael Bolton's exploratory testing. It's mainly actually to make sure the system doesn't do any crazy stuff. Make sure the system does what it's supposed to. And then it's a more structured way of seeing into things, okay? That's normally why you put it outside the team. It's very hard to be responsible for large systems. The system test of large systems is really hard to be responsible within the team. Normally set up in an external team that provides proper test environment and test scripts to be run within the team. But it's the same thing. It's 100% automation. I also put integration, system integration tester. 100% coverage of that too. It's just an example. 50% of the times I bring that in. But there's a very important line which is after the integration tester and UAT. That little small line you see there. On the left of it, it's technical bugs. On the right of it, you're meant to find efficiency bugs and value bugs, okay? If you haven't done the things properly to the left, it's impossible for users to value if the system is the right system, because the buttons don't work, the input fields don't work. How can you measure if the customers get the right value? So it's almost impossible to do it. Just a short thing. But you always have to have proper UAT in it, user acceptance testing. And the UAT here is very simple there, but mainly when I work for customers that buy systems from providers, we create something called a modern UAT pipeline, which is pre-acceptance 1, pre-acceptance 2, and traditional acceptance testing, which is actually just to make sure that the provider has done their testing properly. So I gave you the problem, and I told you a little bit of how I solved it. I don't think there are any questions. Do you have any questions, Cindy and Ulrika? They don't have it, but if you have any questions, just look below and you will find my email address and my mobile phone number. Just give me a call. But if you call from abroad, please try not to call me in the middle of the night. But if you have to, you have to. Now, really take care out there, and I hope to see you. Goodbye.